Fireworks come in every color of the rainbow. Wait, what? How do they make those colors? The fire hotness spectrum goes from red to blue, but that skips green, doesn't it? What's missing? Well, fireworks emit such vivid colors because of how the elements, as in periodic table elements, that are in them behave when they're burned. We can see this on a more controlled scale using an element identifier called a flame test. In a flame test, we burn a substance. Then, using the color of the flame, we can find what elements it was made of. Let's reverse engineer this process. If we know which element we have, we'll know what color it burns. So now, we can focus on figuring out the how. Take barium. In a flame test, instead of burning straight barium, we burn barium chloride, a metal salt. This turns the metal atom into a positively charged ion, called a cation. The barium salts absorb heat and light energy from the fire. The lion's share of the energy goes to barium's electrons. Then, like kids on a sugar high, the electrons get excited and jump to higher energy levels. Metal cations can have more excited electrons because they have more room in their valence, outermost electron energy level. However, electrons don't stay excited forever. They are more stable when arranged in the lowest energy level possible, their ground state. So, when an electron moves from its excited state back to its ground state, it gets rid of its pent-up energy externally, not unlike a kid throwing up after eating too much candy. The color of a flame is the energy, or photons, that electrons cough up as they cool down. This is called photon emission. Each element emits photons at specific, predetermined wavelengths and intensities. We experience this as colored light. This phenomena gives elements the spectral fingerprint, or emission spectrum, we use to identify them. We can find an element's emission spectrum by using a prism to break down the light energy, or photons, that an element emits into specific wavelengths. These are the colors. The color of light an element's flame gives off is indicated by the most intense lines on an emission spectrum. We mix elements' colors like we mix paint colors. Potassium burns purple, but it is almost invisible in the night sky, so purple fireworks are usually a combination of blue copper and red strontium. In the here and now, we enjoy this aspect of the world around us with colorful explosions and pyrotechnic displays. Next time you see fireworks, I hope you have a bang-up time knowing how that fire works.